An orchard has 2,030 trees. The number of trees in each row exceeds twice the number of rows by 12. How many trees are in each row? Well, we have an orchard that has trees, and these trees were set up in rows. So we have a whole bunch of trees here. So here you can see what I'm trying to demonstrate is that we have 2 rows of trees, and in this row there are 5 trees as well as that row. So the statement that the number of trees in each row, so for us it would be 5, exceeds twice the number of rows. Twice the number of rows would be 2 times 2 by, and this time it's not by 12, but I think it's just by 1. So if I was to double the number of rows, 2 doubled is 4, and add 1, exceed it by 1, then I'd have 5 trees in each row, and there's only 2 rows. So that's the kind of a setup we have here. But we have a whole lot more trees, and I was not about to draw 2,030 trees. So we have the number of trees is equal to not the number of rows, but actually we would need to double the number of rows, twice the number of rows, and it's exceeding it by 12. So I need to add 12 more to the row side, so I'll have enough trees. Okay, so let's go back again. How many trees did I draw here for you? Well, there are 2 rows, and in each row there's 5. So it looks like there's 10 trees. And the way that I figured that out was to take the 2 rows times the 5 trees in each row. So let's do that up here. If I take the number of rows and multiply by the number of trees in each row, I should get 2,030. Putting this information about trees into the variable, we'll have r times 2r plus 12 is equal to 2,030. Clearing parentheses, 2r squared plus 12r is equal to 2,030. At this point in time, to make my life a little better, I'm going to take half of each side. R squared plus 6r is equal to 1,015. And I just try and clean up my numbers whenever possible. If every number in the problem is divisible by something, then I do that to clean it up. Now I also need to have the equation equal to 0. So I'm going to take this 1,015 off of that one side and put it onto the other. Now again, my favorite way to solve these types of problems is to actually factor them. Since I have my 0, I know that anything I multiply together to get 0 means that one of these has to be 0. I can break down the first term, r and r, but I need to know what are the factors of 1,015. So again, I'm going to list those for you here off to the side of the paper. This time we didn't have that many factors. 1 times 1,015, or 5 times 203, 7 times 145, or 29 times 35. And I did that by taking this number and dividing by 5, seeing what was left, dividing by 7, seeing what was left, and 29 was prime, so I was pretty much done at that point. I noticed that the difference between 29 and 35 is 6, which is exactly what I want, and I am supposed to subtract. So I'll put in a negative 29 and a positive 35. So now I can take these two factors and say that r minus 29 equals 0, in which case r equals positive 29, or r plus 35 is equal to 0, thinking ahead of myself. R is equal to a negative 35. Now how can you have a negative number of rows? That doesn't make any sense. So the question is, how many trees are in each row? The answer we have is how many rows there are. So we need to take this answer and put it back into the equation up here for the number of trees. So 2 times 29 is 58. 58 plus another 12, I believe, is 70 trees. So for some word problems, it really does help to have a picture to make sure you understand the situation, and then set up an equation and try and solve it. And make sure that you answer the question, not just find an answer to a problem.